we're going to talk about inscribed angles. Yeah, the next one is intercepted arcs. So section 9.5 is all about inscribed angles. So I have 3 pictures that inscribed angle. The section's called angles, but for right now, for box 1, we're talking about inscribed arcs. Okay. So when you have an angle that's inside a circle, like I have here in these 3 pictures, when you have an angle that is inside a circle like that, or like that, or like that, the angle that is inside the circle, then the angle ends up intercepting the arc. So what I mean by that is, like here, when we're talking about intercepting the arc, we're talking about there. Oh, I know. Yeah. Sorry, that's okay. Okay, so the heart of this lesson is talking about inscribed angles. So when we see the phrase inscribed angles, we're talking about an angle whose vertex is on the edge of the circle. So the one vertex is on the edge of the circle here. So this is the vertex that I'm talking about, on the edge of the circle. And the inscribed angle would be the one that is swept out from here. And this is the intercepted arc. Okay, so we have inscribed angles and intercepted arcs. And here is the clutch part about this idea. So I'm going to give you 2 circles, there and there. Okay? And we already learned from the last lesson that if, let's say, like, if this was 81 degrees, then what would this angle be over here? 81. That would also be 81 degrees, right? But when you have an inscribed angle, it means I'm going to have a point that's way over here, and looks something like this. So let's say that this was from here to here, the intercepted arc. From there to there was, let's say that's 100 degrees. Then what do you think that angle would have to be? 100. No, you'd think it'd be 100, right? It would be 100 if it was at the center, if it was a central angle. But it's not. It's an inscribed angle. So it's all the way across. So if you think about it, it's moved twice as far back. So therefore the angle would have to be half as much. Double. Not doubled. So this would have to be 50. Yes, that's exactly right. That's a super important part. So the inscribed angle is half of the intercepted arc. Okay? This is the inscribed angle.
So the inscribed angle is half.
Yep.
Okay.
Here's your inscribed angle. Here's your intercepted arc. And the relationship between the two is the inscribed angle, the little one, the one on the other side, is half the intercepted arc. Yeah. So in the last section, we had a central angle. That was the angle measured from the center. It was the same, equal to the measure of the arc. So like example 81, 81. Now, yeah, the arc is, yeah, the measure of the arc was 81, and then the central angle also 81. However, now something new. We have this piece here, which we're calling the intercepted arc, right? And we have this piece over here, which we're calling an inscribed angle. No longer the central angle, it's called the inscribed angle because it's inscribed on the other side of the circle. Correct, it's not in the middle.
So it's across on the
other side of the circle. It's half. Yeah, that's the relationship that we want to understand. Intercepted arc and inscribed angle. Okay? Okay, so I have one intercepted arc that's highlighted in yellow. Do you guys see it? It's this one here. This is the intercepted arc. Looks like a happy face. Okay? And I have 2 inscribed angles. Do you see them? One's called angle 1, one's called angle 2. What do you think is true about angle 1, angle 2 if they are inscribed to the same angle? They're congruent. They have to be, right? So that's exactly what that says. So this is actually a theorem. A theorem is, remember, just a statement that's been proved, okay?
Whenever we hear theorem, we think of proofs.
Oh man, life is so much full of joy, okay? So, if 2 inscribed angles intercept the same arc, then what can we say? Then they're congruent. So it's just like you guessed, just like you would have guessed in the picture. Angle 1 is congruent to angle 2 only because they intercept the same arc. So no matter where I put around there, right? What about this over here? Would that be the same thing, guys? If I call that 3, will that still be the same? Yeah. 1, 2, 3, they'd all be congruent because they're intercepting the same arc, which is that highlighted one over there.
It's because they're all touching it.
They're all touching, yeah. They're all intercepting on the same arc. So therefore, the theorem says they all have to be congruent. For this one, okay, there's a quadrilateral, meaning a figure, a four-sided figure. It's inside the circle, and then I have 4 points around the circle. All right. So here's what I'm going to ask you. I want you to sort of follow along here, right? This, see how this is broken up into? I could do 4 arcs here. I could do like that one. I could do this one here. I could do this one here. Aren't those nice? And then I could do this one here. Okay, so what's true about all the way around the circle? All those arcs. What do they have to equal?
360.
Every single arc has to equal 300. All of them add together equals 360, right? Okay, now take a look at this angle here, this inscribed angle, okay? No, not necessarily. Take a look at this inscribed angle here, this angle. Would you agree that it makes up this much of the circle?
That'd be 180.
Okay. Hold on a second. Do you guys agree? Do you guys agree with that right there? Okay. Now, take a look. I'm gonna do this in black on the other side. Okay. Let's take a look at this angle over here, this inscribed angle. And would you agree that it's talking about this is the intercepted arc of that right there? Would you guys agree with that? Okay. So then, what is the relationship between these two angles? Are they adjacent? Are they opposite? What are they?
They're opposite angles.
They are opposite, right?
Opposite angles are congruent.
Okay, no, hold on. Are you sure that they're congruent? I can't say they're congruent, but I can say they make up.
180.
Yeah, they make up. That's
Names or they add to 360.
well, they don't have to add to 360, right?
But they're supplementary.
They're supplementary. Very, very good. Okay, so here's what we have. Okay, if a quadrilateral is inscribed, whoops. In a circle, then its opposite angles are supplementary. What does that mean? It means that they add up to 180 degrees. Okay, opposite angles are supplementary. Mm-hmm. Okay, so here we go. So you can consider, so I have a chord and I have a tangent, and there's an angle here. There's an angle formed by the chord and by the tangent. Do you see it, the chord and the tangent there? It's still considered an intercepted arc here, right? This part right here is still considered an intercepted arc, and what's across from intercepted arc on the other side of the circle? What do we call those things? Inscribed angle, right? Okay, so the rule still applies, right? What do you think the measure of that angle should be? 136 divided by 2, right? So it should be 68, right?
And the one above it's 68 also.
This should be 68. Okay? Now what about this one here? Remember, this is the intercepted arc, okay? And this is the angle. Sorry, inscribed angle. Even though it's tangent, it's still technically on the other side of the circle, right?
12, right?
So that should be exactly 112. So it's, even though it looks kind of funny, the same rules still apply for us.
Does that mean that
Yeah, and then you'll notice that 112 plus 68 is going to add to 180 because it's a tangent line, so it has to be 180 degrees. So that's why this one has its own separate theorem. And then it's still an if-then statement. Sorry, yeah, it's not an if-then, it's just a statement. If the measure of an angle formed by a chord and tangent is equal to half the measure of the intercepted arc. So it's exactly what we just showed you before. The intercepted arc, 136. The angle formed by the chord and the tangent has to be half that, 68. Same for the other side. And the reason is because this is a tangent line, so it's got to be 180 degrees. Those two have to add to 180. So the same rules still apply for that. Sorry, it's not an if then, it's just a statement.